Hello everyone, welcome back. My name is Mr. Cobalt, and in this video I'm going to go over the second problem to finding the empirical formula or molecular formula for when you're given a combustion analysis. So in this particular problem, you do have a combustion of a sample. So you're going to have, here it says, upon combustion of a 0.8233 gram sample of a compound containing only carbon, hydrogen, and oxygen. And this compound, when you burn this amount of the compound, it produces 2.445 grams of carbon dioxide and 0.6003 grams of water. And then they ask you to find the empirical formula. So right away, we notice that they're giving us a total amount of the substance that's burned. And the reason that's going to be useful is because we also notice that this compound is made up of carbon, hydrogen, and oxygen. So oxygen is going to be an extra step that we need to find. And we're going to use the original amount of the sample to do that. So this one is going to be a little bit more complicated than the last one we went over, but that's good because this is one of those typical problems. All right, so again, in a combustion analysis problem, the assumption is that all the carbon goes to carbon dioxide, all the hydrogen goes to water. The oxygen in the water and the carbon dioxide, some of that is going to come from the atmosphere because you burn. So the oxygen from the atmosphere gets united here. So we don't know how much oxygen is from the atmosphere and how much was from the sample. So that's why it's important to find the hydrogen and carbon first, and then we're going to subtract those out from the original sample, and what's left over has to be the oxygen because those are the only three elements in there. Okay, so what we need to do is we start like we did before. So we need to take the gram amounts of carbon dioxide and water, convert those to moles of carbon and moles of hydrogen. So we're going to start with carbon dioxide. So we got our 2.445 grams of carbon dioxide. We're going to put that over 1. We're going to then multiply by the molar mass so we can convert from grams to moles. So the molar mass of carbon dioxide is 44.01 grams of carbon dioxide for every 1 mole of carbon dioxide. So grams cancel out. And then we need to go from moles of carbon dioxide to moles of carbon. So we're going to use the mole ratio in the formula. So 1 mole of carbon dioxide is to 1 mole of carbon. So it's a 1-to-1 ratio. So 1 mole of carbon dioxide is to 1 mole of carbon. So the moles of carbon dioxide cancel out. Now I have moles of carbon, so I can do that calculation. So let's go ahead and do that calculation really quick. So it'll be 2.445 multiply across. We got ones, we can ignore those. Divided by the bottom, 44.01 equals, and we get 0.05555 and so on moles of carbon. And then we do the same thing, we set up the same thing using grams of water. So now we're going to set up the water. So we have 0.6003 grams of water. Put that over 1. And then we're going to multiply across. So we're going to use the molar mass of water to convert to moles of water. So again, that's going to be 18.016 grams of water for every 1 mole of water. So the grams cancel out. And then now we can use our formula, the mole ratio in the formula, to go from moles of water to moles of hydrogen. So that's a 1:2 ratio. So for every 1 mole of water, we're going to get 2 moles of hydrogen. So 2 moles of hydrogen. So the moles of water cancel out. Now we have moles of hydrogen. So now we can calculate the moles of hydrogen. So let's do that really quick. So 0.6003 times 2 divided by 18.016 equals, and here we get 0.06664. 0. Yes. 0.6664 moles of hydrogen. Okay, so now we have the moles of carbon and we have moles of hydrogen. This is going to be part of our pseudo formula, so we're good. We want to remember those, so we could put like we can underline them to remind ourselves. So we're going to use that later. Now the last thing we need is moles of oxygen, and then we can do our pseudo formula. So how are we going to find the moles of oxygen? Well, if we can get the grams of these guys and subtract the gram amounts from the original amount, then whatever's left over has to be the oxygen. So we got to convert to grams. So we're going to have to multiply by the molar mass of carbon. So 1 mole of carbon is to 12.011 grams of carbon. So moles of carbon cancel out. But again, we want to put like maybe a star here to remind ourselves that we're going to use these. And then that'll give us the moles, or the grams of carbon. So if we multiply that really quick, 0.05555 times 12.011 equals, and that's going to give us 0.6, let's get 6672 grams of carbon. And then we do the same thing for our hydrogen. So 1 mole of hydrogen is to 1.008 grams of hydrogen. So the moles cancel out. And if we calculate that really quick, we'll get 0.06664 times 1.008 equals, and there we have 0.06717 grams of hydrogen. So now we have the gram amounts of carbon and hydrogen, so we can subtract those amounts because these originally came from our sample. So we subtract that out from the original amount of our sample. And again, what's left over is going to be oxygen. So the grams, so the 0.8233 grams minus 0.6672 grams of the carbon minus 0.06717 grams of the hydrogen, and that'll give us the gram amount of oxygen. So 0.8233 minus 0.6672 minus 0.0717 equals, and I get 0.0844 grams, and that has to be the grams of oxygen in our original sample. So now that I have grams of oxygen, I need to convert that to moles. once I have the moles of oxygen, I have the moles of carbon, moles of hydrogen, then I can do my pseudo formula. So let's go ahead and calculate the moles of oxygen. So here I have, again, 0.0844 grams of oxygen. I'm going to multiply that by the molar mass, so 16.00 grams of oxygen go on the bottom. 1 mole of oxygen goes on top. Grams cancel out. And so if I calculate that out, I'm going to divide that number by 16.00 equals. And the moles of oxygen is 0.00005275. 0.05275 moles of oxygen. So now I have moles of oxygen, moles of carbon, moles of hydrogen. Now I can do my regular empirical formula problem. So now I'm going to write out my formula. So I'm going to do it up here. So carbon, I'm going to write out carbon. Carbon has 0.05555, and then hydrogen has 0.066664, and then oxygen, I just calculated, has 0.005275. So now I have my pseudo formula. So now all I need to do is multiply by the smallest one to get my ratio between them. So it'll be 1 to something. So this is the smallest one. So I'm going to divide everything by 0.05275. That'll give me a ratio of 1 to some numbers of the others. So 0.005275, and again 0.00525. So if we calculate that out really quick, so this would be 0.055555 divided by 0.005275 equals, and that gives me 10.53, which is really close to 10.5. So I'm going to get 10.5 for the carbon, and then if I do this one, I get 0.06664 divided by 0.005275 equals, and that gives me like 12.6633. So I'm going to write that down. So I get hydrogen 12.6, round it to 12.6. Okay. Hello everyone, welcome back, and I found a mistake. So here I corrected my mistake here. This is the actual moles or grams of oxygen. So I corrected that, I corrected this mistake, and so here I got the moles of oxygen here, and then I divided by that amount. So if you get that amount here, so then now I'm back to dividing by the correct amount of moles of oxygen. And so this becomes C, so 1 to 1, or actually C10. This is going to be 12, so we have H12, and we have 1 oxygen. And so that's going to be the empirical formula for the substance. Sorry about that. So sometimes mistakes happen. It's always good to double check. I hope this was helpful. If you like this video, share the video, like it, subscribe to the channel, make a comment in the comment section, and ring the bell for notifications. Thanks for joining me, and have a nice day.